Fix zero-result searches with OpenSearch backoff and smart fallback. This is the pattern you'll be able to implement by the end, which checks for zero results and then recovers by backing off clauses and adding safe synonyms. I'm Professor Pi, teaching search and IR with simple Python. Search systems often hit a hard stop when a query returns nothing. That looks like dead weight for users and lost engagement for applications. OpenSearch Query Relaxation for zero-result recovery is a pragmatic pattern that detects an empty result and then progressively lowers barriers so relevant documents surface. It is not a single model. It is a staged process that trades strict precision for useful recall only when needed. The intuitive idea is simple. Start with the cleanest, most precise query you can. If that returns zero, relax constraints step by step. First, move required clauses into softer clauses. Then add tolerant matches like fuzzy or phrase boosts. The goal is predictable recovery. You prefer the smallest relaxation that yields results. We will build a tiny pipeline that probes the OpenSearch node, indexes one sample document, shows a brittle query that fails, then applies a sequence of relaxed queries until we recover. That gives you a compact pattern you can drop into a search endpoint. Now we will connect to OpenSearch and check health. Now we will run a quick readiness probe. This snippet connects to OpenSearch and checks the cluster is reachable. The OpenSearch client is initialized to talk to a local node over HTTP. The variable OK calls client.ping, which performs a lightweight health probe to confirm the endpoint responds. A true value indicates the process can proceed with indexing and querying. False would suggest connectivity or service issues. The print line surfaces a simple readiness signal to fail fast before building any logic. Seeing ping OK equals true confirms the cluster is up and ready for queries. Next, we will index one document and force a zero hit with an impossible clause. This example indexes a small document and triggers a zero-result strict query. The variable IDX names the index, and client.index writes a single record with a title and year. After client.indices.refresh makes the document searchable, the dictionary Q0 builds a bool query that must match both a title and an impossible year value. The call to client.search executes the strict request against OpenSearch. The printed zero hits shows how an over-constrained clause like an impossible term can suppress recall entirely. This visible zero verifies our failure mode to fix next. Now we will relax the Boolean logic and try again. This code relaxes the strict query by backing off must clauses to should. The query Q1 moves the title and year checks into a should array and sets minimum should match to 1, meaning either condition can satisfy the match. This preserves intent while removing the brittle all-or-nothing requirement that caused zero results. The client.search call runs the relaxed request, and the variable h1 captures the recovered total from OpenSearch. Increasing minimum underscore match would tighten recall. Decreasing it can broaden results further. The printed recovered count confirms that a simple clause backoff immediately surfaces candidates again. Next, we will add mixed precision signals with phrase boosting and fuzziness. This snippet adds a boosted phrase match and a fuzzy match to safely expand recall. The variable Q2 includes a match phrase on the exact title with a higher boost to preserve precision when the phrase appears. It also adds a fuzzy match on a misspelled variant, allowing OpenSearch to tolerate small typos using fuzziness set to auto. The client.search call executes this mixed precision query and S captures the top document score. Raising the boost increases the influence of exact phrases. Relaxing fuzziness broadens recall but can admit more noise. The printed top score reflects a weighted ranking where exact signals outrank fuzzy ones. Now we will wire these stages into a simple fallback loop. This example stitches the strict, backoff, and fuzzy queries into a simple pipeline. The stages list pairs a label with each prepared query, ordered from most precise to most permissive. A for loop executes client.search sequentially and breaks on the first non-zero result, capturing which relaxation stage succeeded. This approach prevents overshooting recall when an earlier cleaner match would suffice. And it also documents the fallback path used. If you reorder stages, you trade precision for speed or vice versa. The printed stage identifies the minimal relaxation needed, guiding follow-up tuning and logging. If you map this toy example to a real search service, the same loop sits in your query handler. Log the chosen stage for analytics. Use a small set of staged queries to limit latency and avoid flooding your index with overly broad requests. In production, you might add rate limits or cache the relaxation decision per query fingerprint. Recap what it is: a staged relaxation pipeline that recovers from zero results by easing constraints. When to use it: when strict queries are failing intermittently and you need graceful recovery for users. One caveat: each relaxation step trades precision for recall, so monitor quality and log the stage. Next step: tune the minimum should max threshold and the phrase boost to find the balance where most recoveries happen without noisy results. That single knob often moves both precision and recall meaningfully. If short practical IR helps, subscribe and watch the rest of the IR videos.